Hello Unreal Engine enthusiasts, welcome back to our channel. Today we're diving into the exciting world of animation constraints in Unreal Engine. In our last video we explored attach tracks and sockets, explaining how they help attach props to characters. However, we also touch on some drawbacks of this method. That's why today we're focusing on one of my favorite topics in animation constraints. So without any further ado, let's get started. Animation constraints are powerful tools that allow us to attach and control objects within our scene seamlessly. They help us create more dynamic and realistic animations by defining relationships between different objects. Now I have a level open, and in this particular level we're going to work with constraints in Unreal Engine. We are going to review the steps required to apply a constraint to a child and create child-parent relationship. We are also going to introduce types of animation constraints that we have available, and once we have a solid understanding of the framework, we're going to switch to another level and see more things in practice. Now what I have in this level is two objects, and the first step required to start the process is to be in the animation mode. Now if you don't have the modeling mode open, then Shift 7 is going to take you to the animation. If you have modeling open, then Shift 8 is going to open the animation mode. Alternatively, you can go in here. I have modeling open. I'm going to go into animation, and you can see Shift 8 is going to take you to the animation. Also, constraints very similar to attach tracks and sockets are timeline driven. What does that mean? It means that you need to have a sequencer ready. I've already created a constraint sequencer. My sequencer is open, and all I need to do is to put child and parent into the sequencer. So it's just as simple as selecting the child or parent, in this case we really don't know, and add both of them into the sequencer. There is no order to that. Now, before we put this into practice, let's go over the steps together really quickly to have a better understanding of what's involved to attach a child to a parent using animation constraints. The reason I keep saying animation constraints is simply because we have other types of constraints like physics constraints, and I don't want anyone to confuse the two. All right, I thought I'd explain it. So the first one is to have everything that you want to apply constraint to on the timeline. The second one is to select the child. Now here's the difference between this and an application like Maya. In Maya with constraints, we always select the driver first and then the driven. In Unreal Engine, we still, just like normal parenting, we still select the driven first. We still select the child first. So you select the child and choose the object you want to constrain in your scene. With the animation mode open, you go into constrain. I'm going to click on this plus button, and we have translation, rotation, and we call that transform constraint, this pair. And then we have scale, parent, and look at. Now with translation, we look after or control the position of the object, the child. So let's say I'm going to click on that, and you can see the eyedropper or the picker comes to life and says, all right, you've selected the child. Where is the parent? Where is the target? That's where you set the target. And that step defines the target objects that will influence the constraint object. So that is our third step. I'm going to select the other car And you can see this line appears, which is kind of showing us the original location of this object, and now it's been moved to here, and this is now a child of the red car. In the animation menu set, we also see that SM car red is now controlling SM car yellow. You can see the arrow indicating that this yellow car is now the driven and SM car red is now the driver. We have few options in there, a cross, a keyframe button, bake, an arrow to move constraints to higher priority or lower priority if you have more than one, but don't worry, we are going to explain all of that. And believe it or not, that is pretty much done. If I go to my yellow car and try to move, you can see it can be moved independently, but if I select the parent, the child has to tag along. So you can see now the yellow car follows the red car. And that was the fourth step. In a nutshell, that's how constraints work. If I go into the parent and expand, you can see there is no keyframes. If I go into the yellow car and expand the transform, we now have a new track called constraints. And because I picked transform, which is going to control the position of the child in relation to the parent, we have a keyframe on the location in X, Y, and Z. Why it's important? We get to that very soon where we talk about how to disconnect the constraints. But you need to be mindful of these keyframes that you have now on the child in the sequencer. Now let's undo and explore other types of constraints, and that is going to allow us to learn more about constraints and the types of constraints that we're going to choose. So again, I'm going to select the child. You can see the constraints track is gone. Let's go into constraints, and in this time I'm going to select rotation. And rotation again is part of the transform constraints in Unreal Engine, which controls the rotation of the child in relation to the parent. So if I select rotation and now select the parent, I'm going to pick the red car. You can see again we have yellow car following the red car, and this time instead of location I have keyframes on the rotation. So all three, roll, pitch, and yaw, they have keyframes on them. And again, while you can rotate the child independently, you can of course select the parent, and both are going to rotate along their own axis. So each car has got a pivot, and once you rotate the parent, the child is also going to rotate along its own axis. Why I'm emphasizing on this? Because you will see that there are constraints that do the same thing but along the parent axis. I'm going to undo again. By the way, try not to undo because, well, sometimes undo mess up your constraints. The only reason I'm undoing is because I want to get to other constraints as well. I guess you know what I'm going with this. Scale is a no-brainer. It's an obvious one. So you select the child, you go constrain, you pick the target, and now if I select the target and try to, I'm going to toggle the snapping, try to scale the parent, the child tags along. In the meantime, you can scale the child individually. That's that. If you want to sort of remove the constraint without undoing something that I'm doing quite consistently, you can actually go in there and delete this keyframe, but the better alternative is to actually remove it this way. So I can just click on this constraint and that deletes the constraint track with it. Now we have just a pair to go through. The first one is parent, and parent attaches object to a parent and inherit transformations. So it basically does translation and rotation with a slight difference. By far, this is the most common types of constraint. So I'm going to select the child, go into parent, select the red car, and you can see we have the relationship showing. And if I go in there, you can see I have constraint track enabled. I also have location keyframed and rotation also being keyframed. This means that I can move again the child individually, but now I can select the target and say I want to move, it follows along. I want to rotate, it follows along. But again, as I said previously, this time the child follows with the axis or the orbit in relation to the parent. So basically it's going to follow the pivot point of the parent, not its own pivot point. So that's the only difference with rotation. It orbits around the parent, not around itself. Now, the next one is aim constraint. An aim constraint ensures objects that you're parenting point towards the targets. So child always looks at the parent. And we do see that a lot in rigging, let's say in eye controls, where the eyes need to follow the eye controls. Now we know the role of the constraints and the steps required. Let's go to the next chapter and bring in a very simple case study and learn more about constraints, how to disconnect them, other options that are involved which allow you to gain more from constraints actually. So just to recap, you first select your object, step 1. Step 2 is to pick your constraint based on the use case. Step 3, you set the target, use the picker to apply the constraint to the parent. You adjust the influence and animate using the sequencer. Let's go to the next chapter. Now we know how constraints work in Unreal Engine. Let's get into more details and talk about specifics. I have Autodesk Maya open. Well, why Maya? Because, well, at the present time, it's one of the prominent industry standard application packages for rigging and animation. As a matter of fact, the studio I work for, Industrial Light and Magic, this application plays a massive role in those two departments. While this application, Autodesk Maya, is very popular in rigging and animation domain, there are some caveats. And I'm going to show you what those issues are and how Epic Games found a solution for those issues. It's incredible. So let's select the driver. Let's select the driven. I'm not going to explain much about this because it's not a Maya tutorial. I'm going to go into constraint and I'm going to pick a constraint. Let's say point constraint. Maintain offset on, add. So what happens? In the driven side, we have keyframes on the driven side, just like Unreal Engine, where we have keyframes in the sequencer on the driven side. So far, so good. Now, if I select the driver, the driven tags along. But what if you want to select the driven and animate it separately? Let's put some keyframes in there very quickly. I'm going to press S, go into frame 20 and press S. Now we have a keyframe, the driver moves, the driven tags along. Now the issue comes along where I set keyframes, manual keyframes on the driven. Take a look at the channel box and see what happens to these blue blocks, and these blue blocks are constraints. As soon as I press S, the keyframes will appear, red keyframes appear on rotation, scale, visibility. No issues there, but those blue blocks will turn green and all of a sudden we have blend point. So what Maya is trying to do is trying to blend the two keyframes and somehow find compensation. Look at that, the animation is now broken. If I set the blend point to 1, it's going to work for us. If I set that to 0.5 and try to keyframe it, it's going to follow along but halfway. So Maya is trying to sort of blend between the movement of the constraints and the manual keyframe that you now assign to the translate. And that can be an issue. Unreal Engine found a really good solution to that. So let's switch to Unreal and see how we can avoid this issue. Here I am inside Unreal Engine. I have two objects in the sequencer. One of them is going to be driver, one of them is going to be the driven. So I'm going to go into animation, select the child, and let's go with the same scenario, translate, pick the driver, and now if I select the driver, the driven will tag along. Now here's the thing, I'm going to set the animation again for the driver. I'm going to go into translate, and let's say I want to start from here. I'm going to go into location, add a keyframe, move forward at the end, and location again. So I have an animation very similar to the Maya scene. But now here's the thing. Halfway through the movement, I want to select the driven, keyframe its translation, scroll to the end, and move it back, and set another key. Look at that. So instead of blending the keyframes, we have an overwrite using this keyframe. The reason that is happening, and you can actually do that, is because of the possibility of having a dynamic offset. So dynamic offset has been turned on by default on any constraint that you have. You can turn it off, but I highly encourage you to turn it on. If I go into this blue guide here and right click, you can see we have dynamic offset turned on. We also have maintain offset, just like other apps, DCCs, which allows you to maintain the offset between the two. Otherwise, the driven will snap to the center of the driver. So I would highly encourage you to enable dynamic offset to be able to override instead of blend when you create your manual keyframes on top of your existing constraints. If you're curious about what's going to happen if I turn off dynamic offset, let's turn it off and see what we can do with this sort of same scenario. So I have the object moving along. Let's say halfway through, we make a decision to add a manual keyframe. This time I'm going to move the sphere up. So I'm going to keyframe, I'm going to go in here, and this time I'm going to move it up. You may have noticed that Unreal doesn't allow me to do that. As a matter of fact, I cannot move it anywhere. It snaps to this location saying that you don't have any dynamic offset available at your disposal. And that's where you need to look for other workarounds in other DCCs like Maya. But in here, with dynamic offset, you can comfortably move objects. You have your keyframe ready to go, and you take it from there. Absolutely incredible. Now, with that out of the way, let's switch to a brand new level. I have more to share with you on constraints. Here I am inside a brand new level. Let's start by applying a constraint to this cup so our character can pick up the cup and puts it in another spot and let go of the cup. So that's the idea of this level. I've got a very rough animation. This is by no means the best animation ever, but you can see the hand gesture kind of gives it away. So the character is going to hold the cup, move it to another spot, and then let go of the cup. Simple as that. So to do that, of course, we know how to do that with attached tracks and sockets, and we want to simulate kind of a similar functionality with constraints in the animation mode. The first thing that I always suggest when you're dealing with constraints is to bring the prop into character's hand or into the right position and pose the character first. It would be a lot easier to pose the character, do your animation. You can always repurpose this cup to make sure there's no geo penetration, so on and so forth. And only then you can just start with your constraints. Now, to do that, I need to have the cylinder, which I modeled in the modeling mode. Fairly simple prop I've got right here. The idea is to bring it into the sequencer so we can sort of benefit from it. It will receive all the keyframes coming from the constraints, and we can move forward. So what I'm going to do, at least to be organized a little bit, I'm going to go to edit and I'm going to rename, call that SM_cup. Let's bring that in, add SM cup. So I've got the child and I have the parent ready to go. Let's bring it into the position. So I'm going to roughly bring this into a rough position. All right, that should do it. So we have that in place. And if you have any animation that comes after this, you can actually keyframe the character and bring it into this position. That's another benefit of having constraints, because as I mentioned before, we do have dynamic offset that allows us to put individual keyframes on the child and animate it independently. Now it's time to create constraints, selecting the child, picking the constraints, and because I'm going to lift the cup and spin the cup, I definitely need to use parent. I'm going to select parent, and now here's another part where it differs from a typical, let's say, Maya workflow or other DCCs, where you always select the controls to connect the prop to. We actually want to select bones, because there are times when you want to switch between IK, FK, and with controls, if you switch from FK in this case to IK, those controls will be invisible and you get IK controls instead. And that's where you run into problems. Whereas if you connect them into bones, nothing is going to happen. So definitely be careful about that bit. I'm going to click on the model because we're dealing with multiple objects. And we know from our previous tutorial that there is a bone called hand, and we've got hand left and right, and this one is left. Also, if you are getting props from, let's say, marketplace, and this marketplace is meant to carry a prop, usually you get a bone prop like weapon or bag, something that you can attach your prop to. So make sure that you're actually investigating if there's any sockets or if there's any bones specifically made for that prop. Well, use that instead. For now, I'm going to go with hand left. Now, this should ideally carry through. And let's say I'm going to put the cup here. Going to give myself a little bit of room, like so. So if I expand the character just to be able to see where exactly it's going to do that. Yeah, seems like it's around here, frame 55, where I want to disconnect the constraint. Now to disconnect the constraint, it's very straightforward when you're using constraint. Unlike attach tracks where you need to right click, trim to left, trim to right, delete the end key that Unreal always leaves behind, this is really clean. If I look at the child in the constraints tab or rollout, of course we have the relationship between the cup and the hand, and I've got the cross to be able to remove the constraint. I also have this little keyframe which we call compensation keyframe, where it allows the cup to get disconnected using a simple keyframe. So on frame 55, I'm going to press, and you can see now I have a key in the location, and now you can see this blue color is no longer there. The constraint is there, but it's inactive. Now if I move forward, you can see that we do not have the constraints anymore. So that's how actually you go and enable and disable constraints. Now here's the bit that might get a bit interesting, where you may have this character reaching out for the cup again, and you would like to go and enable that again, or another character may go and pick up the cup. So the idea is not to reuse the constraint. If that's what you want to do, replace it with a new one. So replace this cup with a new one if you want to reuse your constraint. Otherwise, you may run into some glitches. Also, if you apply the other hand and have two targets controlling one source, sometimes you may run into some funky keyframes. So if that happens, simply go into your outliner. You might see a spike. Curve editor, you might see a spike here and there. Make sure all the keys are set to auto tangent, smart auto tangent. Didn't happen in this particular scenario, but sometimes you have a snap or a jump. If that's the case, it might be a glitch. Go to your curve editor and flatten the tangents. That should fix the issue. So if I were to compare this method to attach tracks and sockets, pros would be it's the most flexible option. As you can see, the constraint is toggleable, so you can actually toggle this on and off quite effortlessly. And you benefit from dynamic offsetting as well. So you can apply dynamic offset at any point of time. If you wish to re-keyframe the constraint, you can use compensate key to re-keyframe the constraints if you want to. And none of these options are actually available when you're trying to attach a prop to a character using tracks. There's also this very last option, bake, in case if you wish to bake keyframes on this object right here. So I can go to the very first frame where the character picks the cup, and I can right click and say bake. If I go into transform, you can see location, rotation, and scale now have been keyframed. Every single frame has got a keyframe now. To show you this, I can open sequencer curves window to see how it works. So you can see everything has been baked and ready to go. And now you can use the baked version instead once the animation is approved. All right, that should do the trick for this tutorial. Believe it or not, we have a third way to connect props into characters or attach one object as driven to a driver, and that is using a snapper tool. I'm going to dedicate a very short video or tutorial to that right after this, and hopefully after the third video we cover everything you need to know about attaching a prop to another static mesh or skeleton, and hopefully you will enjoy and use all of these techniques in your own projects. As usual, thank you very much for your support. I hope you found this video useful, and until the next video, see you guys later.